Reality may not be built from simple blocks, it may be built from patterns that repeat forever. Welcome to Information World. Imagine zooming into the universe. Galaxies become clusters, clusters become filaments, filaments form vast cosmic webs. Now imagine zooming further, not outward, but inward. Cells, molecules, atoms, particles. What if the same structure appears again and again at every scale? What if the universe is not just large, but self-similar? What if the universe itself is a fractal? A fractal is a structure that repeats its pattern at different scales. No matter how much you zoom in or out, the same kind of shape keeps appearing. Classic examples include snowflakes, coastlines, clouds, lightning bolts, tree branches, blood vessels, and even the human lungs. These patterns are not perfectly identical at every level, but they are statistically similar. Nature seems to love fractals because they are efficient, scalable, and stable. Now here's where things get interesting. When scientists began mapping the large-scale structure of the universe, they expected matter to distribute smoothly as we zoomed out far enough. But what they found instead was something very different. Galaxies cluster together. Those clusters form superclusters. Superclusters connect into long filaments surrounding vast empty voids. The result looks eerily similar to neural networks or branching systems found in biology. This cosmic structure is called the cosmic web, and it stretches across billions of light years. What shocked researchers was that even at the largest observable scales, matter does not become completely uniform. Instead, patterns continue to repeat. This raised a serious question: does the universe have a preferred scale, or does structure repeat endlessly? If the universe is fractal, then it has no true average structure. There is no final level where complexity stops. This challenges one of the foundational assumptions of modern cosmology, the cosmological principle, which states that the universe is homogeneous and isotropic at large scales. In simple terms, it assumes that if you zoom out far enough, everything should look roughly the same everywhere. But what if that assumption is wrong? Several studies have shown that galaxy distributions exhibit fractal-like behavior up to hundreds of millions of light years. Some researchers argue that the universe transitions to uniformity beyond that. Others argue that we simply haven't observed far enough yet. Our observable universe may be too small a sample to detect the full pattern. If the universe truly is fractal, then our models of cosmology may be incomplete. The equations describing expansion, dark energy, and matter density all rely on averaging the universe at large scales. But fractals resist averaging. They break smoothness. They preserve complexity at every level. This brings us to a deeper idea: what if fractals are not just a feature of the universe, but its fundamental architecture? Look at physics itself. Quantum mechanics describes reality at the smallest scales, while general relativity describes the largest scales. For decades, scientists have struggled to unify them. What if the reason they don't fit neatly together is because reality itself is scale invariant? What if the same organizing principles apply everywhere, but our equations are only approximations at certain levels? Some theories of quantum gravity suggest space-time itself may be fractal at the smallest scales. Instead of being smooth, space-time might have a jagged, self-similar structure when examined near the Planck length. At these scales, distance and time lose their classical meaning, and geometry becomes irregular. In fact, calculations in certain approaches to quantum gravity show that space-time appears to have a fractional dimension at extremely small scales, not quite 3D, not quite 2D, but something in between. This is a hallmark of fractal geometry. So we may be living in a universe where space-time is smooth only because we are too large to notice its roughness. Now consider something even more unsettling. The human brain is also fractal. Neurons branch in self-similar patterns. Brain activity displays fractal rhythms. Even our thoughts show scale-free dynamics. The same mathematical tools used to analyze galaxy clustering are used to analyze neural networks. This has led some scientists to speculate that the universe and the mind may share the same organizational logic. This does not mean the universe is literally a brain. But it does suggest that intelligence and structure may emerge naturally from fractal systems. Fractals maximize connections while minimizing energy. They are efficient information carriers. If consciousness arises from complex networks, then a fractal universe may be especially suited to producing observers like us. Now let's push this idea further. If the universe is fractal, then there may be no true boundary between the very large and the very small. What we call particles could be miniature universes. What we call the universe could be one structure inside something far larger. Just as atoms were once thought to be indivisible, the universe itself may not be the final level of reality. Some speculative theories propose a nested universe model, where universes exist inside other universes, repeating across scales. While this idea sounds extreme, it is mathematically consistent with fractal geometry. In such a model, the laws of physics could repeat with slight variations at each level. This could even explain why physical constants appear finely tuned. If reality is fractal, then many versions of universes may exist at different scales, and we happen to inhabit one where conditions allow complexity and life. Fractals also change how we think about infinity. In a fractal universe, infinity is not just about endless size. It is about endless detail. You don't reach infinity by traveling outward forever, you reach it by zooming inward forever. Complexity never ends. Structure never fully dissolves. This idea resonates deeply with philosophical and even spiritual traditions. Many ancient philosophies described reality as layers within layers, worlds within worlds. The microcosm reflecting the macrocosm. As above, so below. Long before modern science, humans sensed that reality might be recursive. Modern mathematics now gives that intuition a precise language. But there is a darker implication too. If the universe is fractal, then prediction becomes harder. Fractal systems are often chaotic. Small changes at one scale can produce massive effects at another. This sensitivity may explain why long-term prediction in cosmology, climate, and even human behavior is so difficult. Reality may be deterministic in principle, but unpredictable in practice. This also raises questions about free will. In a fractal universe, every level influences every other level. We are not isolated entities. We are patterns embedded inside larger patterns. Our choices may echo upward and downward through scales in ways we cannot perceive. Now consider time. If structure repeats across scale, does time also repeat? Some models suggest time itself may be emergent rather than fundamental. In a fractal reality, time could be a pattern of change repeating at different resolutions. What we experience as linear time may be just one slice of a deeper recursive process. This aligns with ideas in modern physics where time breaks down at quantum scales. It also aligns with the intuition that time feels different depending on context, scale, and perception. The universe may not be a story with a beginning and an end, but a pattern with no absolute start or finish. So what does all of this mean for us? It means we may not be insignificant dots in a cold universe. We may be expressions of the same pattern that shapes galaxies and space-time. Our existence may not be accidental, but a natural outcome of a universe that builds complexity into its very structure. It also means that understanding reality may require a shift in thinking. Instead of looking for final answers, we may need to look for recurring principles. Instead of reduction alone, we may need pattern recognition across scales. Science is already moving in this direction. Network theory, complexity science, and fractal mathematics are being applied across physics, biology, economics, and neuroscience. The universe is increasingly seen not as a machine, but as an evolving pattern. And perhaps the most profound idea of all is this: if the universe is fractal, then we are not separate from it. We are it, expressing itself at one particular scale, for a brief moment, with awareness. The same geometry that shapes stars may be shaping your thoughts right now. And if that's true, then understanding the universe may also mean understanding ourselves. If you enjoyed this journey through one of the deepest ideas in modern science and philosophy, make sure to like the video and subscribe to Information World for more mind-expanding explorations.